Hi everyone, this is another event, IoT developer event. Today we have a great topic which is called Cumulocity IoT Edge running on Kubernetes. Today I have with me actually a whole team, but mainly two guys who will present. This is one Nick, which is the product manager for Cumulocity IoT Edge, and which is Pascal, which is also an IoT and leading the R&D team there. The housekeeping rule, as always, we will have the Q&A in the end of the session. During the meeting, the mics are muted. If you have any questions in the meantime, use the chat. We have, as said, a lot of other colleagues in the meeting as well, which can answer your question in the chat. If it's not answered, of course, we will take the chance to answer it in the Q&A in the end of the meeting. The meeting will be recorded. It will be uploaded to YouTube after this session. So that's everything from my side. Now I want to hand over to Nick. Let's get it started, Nick.
Thank you, Stefan, and thank you everyone for joining this call, and a very warm welcome from my side. Let's just share the presentation. Bhaskar, do you have it ready?
Yeah, I can share.
Thanks. All right, thank you, Bhaskar. Can you please go to the next slide? So I'm here to really give you a first introduction of Cumulocity Edge and a bit of a motivation why we've chosen to go to Kubernetes and our Kubernetes journey with that. So Edge is a Cumulocity IoT platform delivered as an appliance and designed to run on industrial PCs and local server, and as of 10/17 on single node Kubernetes cluster. Edge has the same set of capabilities as our Cumulocity cloud platform. And if you are, by the way, interested in a cloud, in our view to cloud to edge continuity vision, please do check out our Cumulocity IoT YouTube channel. You will find the presentation there from Summer user group. So what are the reasons to use Cumulocity IoT Edge? Well, one of them is autonomy. If you can run this on a local server, a local machine, and collect all of the data without connecting that to the cloud, if you in an isolated environment, that's one of the reasons that we see with our customers. The other one is data reduction. If you analyze big amounts of data coming to the edge, you can clear it before pushing to the cloud and reduce the amount of data that goes direction cloud and reduce some traffic. And the other one is latency optimization, which is if you have some high frequency analytics use cases and you want to run as close as possible to the machine floor, that's how you can, that's where you can optimize Cumulocity IoT Edge. Pascal, can you please go to the next slide? So as our Edge solution matured, we have seen a trend in adoption and evaluation of Kubernetes among organizations globally. And some research data for you, probably interesting only to the product managers, but in any case, as of 2023, we've seen, and the research shows 96% of organizations either using or evaluating Kubernetes. And 93 of those Kubernetes Kubernetes adopters are considering Edge are considering Kubernetes on the edge. However, only 7% of them are in full production with all of Kubernetes complexity. So to simplify and improve our edge computing, we at Software AG Cumulocity team say challenge accepted. Bhaskar, and that's the time when you click the next button. Thanks. So please welcome Bhaskar representing our team, giving you an overview to Kubernetes and Edge on Kubernetes journey.
Thank you, Nick. Hi, welcome everyone. So before I get into the details of Kubernetes and how Edge can be deployed on Kubernetes, I want to first look at why we wanted to have Edge deployed on Kubernetes. Edge appliance, as you all know, is delivered as a VM image, a software appliance, which you can install, very simple to install, driven by UI, and install, upgrade, and manage Edge. That experience and that simplicity is what our users like of Edge appliance. However, there are other use cases which actually require much more control on internals of how Edge is deployed, a better way to automate and manage Edge, monitor Edge, as well as resource management control that our users would need. So what we have thought is basically Edge can be, or Cumulocity platform can be installed on a Kubernetes cluster. In this case, it's a single node Kubernetes cluster for Edge, which gives a finer control of installation, upgrade, resource management aspects of Edge. Also, with Kubernetes, there are a lot of advantages that come. Basically, Kubernetes being cloud native. Kubernetes is an open source platform, a cloud native platform that allows, in the case of Edge, to leverage the CI/CD principles and much more native, using native Kubernetes resources to deploy Cumulocity platform. And Kubernetes, allows you to manage containerized workloads and services that also is leveraged by Edge, or Edge being deployed as using an operator. Again, a Kubernetes construct which lets us manage the containerized components that form the Cumulocity platform, using both compute and storage capabilities provided by Kubernetes. As I said, Kubernetes manages containerized and workloads and gives us a very good orchestration layer through the operator, a concept of Kubernetes. And we leverage, our Edge operator leverages those constructs to provide a better experience for our users, and much more fine-grained APIs through which you can automate the deployment and declaratively configure the edge deployments and upgrades. Going to the next slide, it's here I want to compare between different deployment options provided or deployment options provided are available in Kubernetes. One is Helm. Helm, as you know, is a package manager managing the YAML manifests that actually end up creating or updating the Kubernetes objects or Kubernetes resources. It can be templatized. You can basically provide the variables and deploy your application based on certain changes to the configurations as provided by that particular Helm chart, which deploys that application. A single command, it's usually Helm install, and that would install the entire application and its dependencies. It can be version managed. Helm inherently provides a way to maintain the release history. But Helm actually is geared towards day one of operations, like managing mostly the life cycle of the application, install, upgrade, and delete. But there are many other needs while application is installed and to manage the application, like taking backups, restoring from backups, and many other aspects that operations team would take care of starting day two of the deployment of an application. That's where this concept of Kubernetes operator comes into play, where it helps the operators or operations teams or the application ops teams to basically automate those day two kind of operations, backup, restore, and monitor, log collection, things of that sort, and also provides a better way of managing the deployment of an application or complex application which is composed of multiple components and their interdependencies, which can be coded into the operator. I'll delve more into the operator, what kind of capabilities an operator provides, and how those are leveraged in deploying Edge on Kubernetes. However, both Helm charts and Kubernetes operators do more or less the same things, but and hence we are in effect for deploying Edge on Kubernetes. We are leveraging both Helm charts where necessary and using the Kubernetes operator. We call it as Edge Kubernetes operator, which actually orchestrates various Helm charts for deploying different components that form the Cumulocity platform. Moving on to the next, what is a Kubernetes operator, and why Kubernetes operator makes sense or relevant in this discussion. So Kubernetes operator, as Helm chart, is also a method of packaging, deploying, and managing Kubernetes applications or applications that can be deployed on Kubernetes. And operators are nothing but extensions of a Kubernetes concept called controllers and resources. So Kubernetes operator is a way of extending already the capabilities on which Kubernetes itself is built. That capability is also provided for application deployer or DevOps teams to basically code in their application deployment and management capabilities using the native Kubernetes capabilities or extending the native Kubernetes capabilities. As I said, why Kubernetes operator? Helm charts or Kubernetes operators actually are relevant when you are deploying applications which actually need a lot of domain knowledge, how the application, what are the different components that form that application, their interdependencies, the complexities involved in taking backups, recovery, monitoring, logging, things of that sort. And Kubernetes operators or the custom operators that we build can be these processes can be programmatically weaved into these operators, and that's where the Kubernetes operators are valuable in deploying applications which are complex and comprise of multiple components with their interdependencies. So how does a Kubernetes operator work, or what actually it does? So Kubernetes operator, before we discuss about the Kubernetes operator, Kubernetes itself has some core resources or native resources like pods, config maps, secrets, ingress, and other resources. Kubernetes also provides a way of extending or introducing custom resources. For example, a core resource like deployment looks like this. However, we have introduced a custom resource for deploying Edge, which is basically called Cumulocity IoT Edge. And this is a snippet of that custom resource. So what happens with the custom resource in Kubernetes? So Kubernetes has controllers like replica sets, deployment, and daemon set, etc. These are the controllers which actually ensure that the resources are, or controllers manage these resources. For example, replica set ensures that the number of replicas that you would want to have, number of replica pods that you want to have, is always maintained. In the same way, deployment manages the pod and ensures that the pod is always running. And if for some reasons the pod is not up or crashes, deployment ensures, or deployment controller ensures that the pod is brought back online. Same with the daemon set, one other controller which actually ensures that a pod is always running on every worker node that is part of the Kubernetes cluster. So what an operator does is operator is an extension of a controller, or a controller which actually watches the custom resource and does whatever is necessary to ensure that the custom resource, the changes in the custom resource are actually transformed into the Kubernetes core resources are, the core resources are in place. So what happens every time a custom resource which the operator is listening to changes or gets created, operator gets a notification. It starts something called reconciliation loop. What it does is it basically observes the actual state of the cluster, analyzes the differences between the desired state, which is represented by the custom resource, and ensures that based on the logic that is built into the operator, or custom logic that is built into the operator, ensures that the desired state matches or actual state matches the desired state. And it's a loop which keeps operator keeps listening to the custom resource. Any changes to the custom resource are basically ensured that they are reflected in the actual state. So why we decided to go with creating an operator for deploying Edge. First, to start with, what is an Edge operator? As any operator, Edge operator packages the Cumulocity IoT platform components, allowing the users to deploy, manage them as basically a Kubernetes application. As I said, Edge operator defines a custom resource called Cumulocity IoT Edge. The operator actually watches that custom resource and manages Edge state accordingly. Through operator, you can manage the lifecycle of the Edge itself, install, upgrade, updates, and also configure Edge via this custom resource. I will show you exactly what are the details that custom resource carries and what kind of configurations are possible via the custom resource. So this is what Edge operator does, but why Edge operator? As I said, operators are geared towards deploying and managing complex applications, stateful applications, which require in-depth knowledge of how application or what comprises of the application, what components, how their interdependencies work, and very platform-specific tasks like backup, restore, monitor, and also operator. Also, since it's watching the actual state of the system, it also can basically, depending upon certain aspects of the application to be up and running, it can heal or repair, self-repair, which actually improves the resiliency of the application. As I said, complex manual operational tasks are simplified with the configuration that is possible via custom resource, and custom resources usually are exposed by Kubernetes as Kubernetes native Kubernetes API, through which you can control or change or update that custom resource, and that way it's very easy to automate complex operational tasks. So the next is I would want to show you how simple and straightforward is deploying Cumulocity IoT Edge on Kubernetes. I'll switch to my WSL environment. One moment. Yeah. So I have a Windows machine where WSL is enabled with Ubuntu operating system running. So before that, I'll show you the user guide. This is the user guide that we have. There are a couple of a quick start guide, which actually gives you not more than 4 or 5 commands through which you can start from installing Kubernetes, a lightweight Kubernetes called provided by Rancher called K3s. So I'll start installing K3s, installing Helm that is required to basically deploy the operator itself. And then I will update the custom resource or introduce a custom resource, which this operator will listen to and start the deployment of Edge. So to start with, I copy the command which actually installs Kubernetes or K3s. We started installing K3s. It's downloading it's installed the K3s and started the K3s. So basically K3s is installed successfully. Now I go back to the command of the documentation and install Helm.
I'm sorry to interrupt, but are you able to scroll in a little bit, to zoom in a little bit, so the text is bigger?
Oh, is it? Okay.
Yes, perfect. Thank you.
Makes sense. Okay, thank you. Okay, now I'm installing the operator itself. Operator installation, we have provided a simple script which actually can be downloaded from this URL. So this command actually downloads and runs that script. This automatically installs the latest version that is available, which is 10.17.00 of the operator. So now actually operator is hosted in, or the operator assets are hosted in a Software AG or Cumulocity repository, and we need credentials to access that repository. The credentials are Edge is the user that I'm using, but at the end of this presentation, I'll share a link to the credentials that you can use if you want to try out. So I have the credentials. So now you can see that the operator is installed and it must be running now. I'll just check the operator pod, whether it is running. Namespace in which the operator and the Edge would be installed is by default C8Y Edge, but you can control that based on your requirement by passing certain inputs to the command. So here is the operator. This is the pod in which the operator is running. It's ready. 2 containers of that pod are up and ready. So now we can create the custom resource. The custom resource actually is a YAML file, a manifest, which you can update. This is a sample custom resource that we have provided, which comes with, I'll show you that. This is the simple configuration, the simplest configuration that is necessary for deploying Edge till here. So to the version that you want to deploy, the license key, basically the key for the domain against which you want to deploy Edge. Here I'm using myown.iot.com. This is the domain that the license that is provided in the sample file comes with. And I'm just adding an email called myown@iot.com as the email. Till here, it's the basic the configuration that is necessary for installing Edge. I'm adding a couple of more lines to ensure that the Edge is connected to a remote tenant or a cloud tenant for us to basically manage the Edge from that from a cloud tenant. So this is the tenant that I have in one of our deployments, internal deployments of Cumulocity cloud platform. That's the domain name that I'm giving. I'm also you can also provide the certificates with which you want to configure your Edge. Those are optional. If not provided, operator will generate self-signed certificates, and the same when the operator or Edge is registering itself as a device in the remote tenant or a cloud tenant. There also you can provide your own certificates, but if they are not provided, the operator will generate self-signed certificates and use them. So in this case, I'm using this manifest to create the custom resource, and the custom resource name, as I said, is the kind is Cumulocity IoT Edge. The name that I'm creating the edge with is C8Y Edge, and the namespace into which I'm creating the custom resource is C8Y Edge again. So I'll go back to the and you just have to use kubectl apply C8Y Edge sample, the YAML file that I have shown. So now it has created the custom resource. I'll go back to the documentation to see what the next step is. Next step is to verify the Edge installation. So going there. So to monitor the Edge the custom resource that you just created, just describe the custom resource. The custom resource name is C8Y Edge, and it is created in the namespace called C8Y Edge. So I'm just copying the command which describes this particular custom resource. So this is the custom resource. It first shows the definition itself, but the real content is here, the spec. This is the resource that we have applied. But it looks like okay, I think the changes that. Okay, see that. Okay, I'm sorry. I opened probably a wrong file. This is not the file. Oh no, here. Sorry. The cloud tenant is also there. My bad. So while the operator is installing, it keeps generating events against the custom resource. So those events can be watched by this command. So if you look at it, it started validating the, basically doing a semantic validation. And it said validation has passed. It started installing the logging operator. This is a component which actually enables us to collect the logs of all the different containers that form the Cumulocity platform and other containers that are introduced by Edge for remote connectivity and other aspects. So this is the logging operator, and so you can follow the installation steps that that the operator is taking. It installed the operator, so it's finished. It installed the logging operator. It finished installing the logging component, waiting for the logging component to be ready. It waited and successfully received a note, a response back from the logging server that it is ready. It started installing Mongo. As you all know, Mongo is the persistent layer used by the Cumulocity platform. So it installed the Mongo. For installing Mongo, we use a Mongo operator. So it first installs the operator, then it installs the Mongo server. Waiting for the Mongo server to be ready to continue, it figured that Mongo server is up and running. Then it installs a microservice registry, basically a registry that an internal private registry that is used for hosting the microservices, and it's basically waiting for microservice registry server to be ready, up and ready, before continuing with the installation of Cumulocity core components and other. Okay. So now you see it started. It finished installing the microservice registry. Then it started installing the Cumulocity core components. Finished installing and waiting for the Cumulocity core to be up and running. While this takes around 5 or 6 more minutes. So while the operator is installing the platform, we move on to the PowerPoint and cover some more details. So this is the deployment diagram of Edge on Kubernetes. This section depicts the operator and the operator watching the custom resource, and basically triggers a reconciliation loop. And when a custom resource is updated, it creates or updates first to the logging operator component or logging component, which comprises of FluentBit and FluentD ports. Then moves on to deploying the Mongo database. Then third one is microservices registry, as we have noticed in the events. Then fourth is Cumulocity core components, which comprises of the graph server and other services that are necessary for exposing the ports and allowing external access to the Cumulocity core graph server. And also the next one is fifth deployment, which is the microservices that are necessary, like the analytics engine, smart rule engine, OPC UA management service, and some other capabilities that are necessary for you to upload the custom microservices that you want to host on the platform. And also creates a thin edge pod or thin edge deployment through which we enable the remote management of the whole edge system or edge instance from a cloud tenant. So to moving on, a much more description of the custom resource, the Edge custom resource. This is the spec of the custom resource, or this is the one a snippet of the custom resource. The part here is group, version, and kind information. Then the metadata of the resource itself. These are the basic constructs of any Kubernetes resource. Then the spec is exactly the details of the edge itself, whether it is the version, license key, the company which is required to create a tenant in Cumulocity, the domain with which you would want to deploy Edge, and the email basically for the user that gets created, the admin user that gets created for the Edge tenant. This is the email that is used. Then when you describe actually the resource, it also shows the status. At the end of the deployment, once everything is ready, the state shows ready, last deployed, and the generation that was deployed, generation of the resource that is deployed, the version of the Edge that is deployed, and some help commands like commands required to download the logs, diagnostic logs, and also one more command that actually allows you to download the self-signed certificate that is used to register Edge in the cloud platform or cloud tenant. So that's basically controller updates the status, or controller or operator updates the status. I'll show you the status once the Edge is deployed. So you can find more details of various options that are available in custom resources or custom resource for you to configure. Apart from version, license, company, and domain, you can configure the secret that contains the TLS certificate or key and certificates that you want to use. If they are not provided, as I said, operator will generate self-signed certificates, but if you want to use specific certificates that you acquired from a valid certificate or trusted certificate authority, then you can provide those details as a secret to the resource. Then email. Then cloud tenant, we saw the cloud tenant details, the domain name, and the certificate that you want to provide to register Cumulocity or register Edge with a cloud tenant. Cumulocity needs some persistent store, like for the database and the internal microservice registry, and also for logging component, it needs the storage. So you can configure the storage by default when they are not configured. The assumption is the Kubernetes on which you are installing Edge has dynamic provisioning of the persistent volume enabled, in which case you don't have to provide the storage class. Many other details, like you can configure the resources like CPU and memory allocated to the core parts, to the Mongo parts, and other microservices parts. If I go to the core part definition, you can provide the resource limits, and the resource limit structure is here, but you can provide the CPU and memory limits the same way in the MongoDB. MongoDB by default is installed with a known username and password, but you can provide your own username password as a secret. The same way, Mongo, there are two deployment options for Mongo. Mongo managed by the operator itself, or you can also configure external Mongo, which is managed separately out of the scope of operator, and still the operator can ensure that the Cumulocity platform that it installs actually connects to the external Mongo that is deployed elsewhere, either within the same cluster, not managed by the operator, or in a different cluster. So for enabling that, you need to provide the details of the Mongo connection string of the external Mongo, and if the external Mongo is configured with a TLS connection, then you need to provide the TLS secrets, and also in case of internal Mongo or Mongo managed by operator itself, you can provide the resource limits and resource requests. So many configurations possible. So it's all detailedly mentioned here. Okay, let's move back to the presentation. I think this is it. Yeah, so you may ask when and why we would want to use or deploy Edge on Kubernetes versus using the erstwhile Edge appliance. In general, Kubernetes Edge on Kubernetes presents a cloud-native solution for delivering, deploying, and managing Cumulocity Edge. As I said, it's declarative configuration. The configuration that we have seen is very easy to change the configuration of your deployed Edge. You can automate. And also these configurations you can enable using or follow the GitOps model, having the configurations stored as or versioned and kept in a repository, and you can enable GitOps to deploy and update edges. Standard or Kubernetes standard way of logging and monitoring. Monitoring, operator provides some Prometheus-based metric endpoints, so you can basically ensure that any external Prometheus enabled dashboarding or monitoring tools that you have, you can integrate and start monitoring edges. Logging, as you saw, logging is managed within the or by the operator, or collecting the logs from various parts is managed by the operator via the logging solution that we have in place. So you can also use the output that is generated out of that logging solution to basically aggregate in an external log collector. Simpler automatable backup and recovery procedures. One other important reason that some of our customers are basically moving away from hypervisors, and they already have a Kubernetes ecosystem in their IT landscape, so they can leverage Kubernetes ecosystem, the rich tooling that comes with that, and also the expertise that you have in-house in Kubernetes, Kubernetes as a tooling. That's so. But anyway, Edge on Kubernetes is complementing Edge appliance or software appliance. It's not replacing. Both of them are available, and they serve different use cases depending upon what you have in place in your ecosystem, and leverage accordingly different flavors of Edge deployment. So we're back to the demo. So So now you see, yes, now you see it has after Cumulocity platform, waiting for Cumulocity platform, it said it is ready. It created the required tenants. It is downloading streaming analytics, the streaming analytics builder, the cockpit application, device management application, and administration application, and updating those applications, and also install the microservices like Apama control, the OPCO management service, smart rules, and it also installed ThinEdge. ThinEdge actually registers itself as a device in the local Edge and Cumulocity platform, or in the Edge itself, and also it is trying to register the Edge as a device in this tenant. But there's one other step that we need to do to ensure that the certificate that the ThinEdge is trying to use to connect to the cloud tenant is trusted by is known to the cloud tenant. So basically, I'll go to this cloud tenant. Before that, I need to download the internally generated certificate, for which there is a command that is described in the documentation. If you go to the connecting edge, so this is the command that actually allows you to download the generated certificate. Before that, you can also so as I said, the commands like help commands like download logs is shown here. This is the command that you would use, or script that you would use to download the logs. I will also show you another way of getting the diagnostic logs from remotely from the cloud. And also, this is the command that you can use to basically download the certificate that actually was generated by the operator. So so this is the certificate. You need to copy that into a basically copy that into a file. And log into the cloud. This is my cloud tenant that I have provided while configuring Edge. So I go to the device management app and trusted certificates. So add a trust certificate. I just name it as come and drop the file here. So this is the file. We need to enable the auto registration and also enable this certificate. Add the certificate. Now, if you go back to the devices, a device named as myown.iot.com should appear here. And also, the ThinEdge should also create an event saying that it has registered the certificate, it would show up anytime. While it is trying to register, we can log in into the Edge itself. For that, we need to know the IP address of Edge, and that's described in accessing Edge. So the operator has created a service called Cumulocity Core in the same namespace. If you here to see device ID, this particular thing is registered on the cloud. So the operator has already registered the Edge with the cloud tenant. Let's say. So this is the service that it is operator has created to expose the ports 443, 1883 for MQTT, and 8883 for MQTT or TLS. This is the external IP. For me to access access the Edge as domain with the domain name, I have to update my host file. So this is the host file that I have. Let me do. I think I updated the host file already. So I have added 2 entries to my host file with the IP address that we have just seen. And the domains are myown.iot.com for accessing the Edge tenant or Edge tenant domain. And this is the management tenant domain of the Edge instance. So let's try to log in into Edge. Since this myown.iot.com is or the server is running with a self-signed certificate, it's the browser complains that it is not secure. I'll anyway proceed with it. And initially, when you start with the Edge tenant or Edge tenant is created with a known user and password. Admin is the user. Admin pass is the password. As soon as you log in for the first time, platform forces you to update the password. For that, you need an email ID with which that user was configured. If you remember, we had passed myown.iot.com, myown@iot.com as the email. So we'll use that email ID and the new password. Okay, so the password is changed now. Again, log in again. The new password. Now you have logged in into Edge, and this is as good as any other tenant. Yeah, you can create users. In the ecosystem, you have default applications and some microservices, the default microservices for Apama analytics engine, OpenSeo management service, and the smart rule.
Laska, we are running out of time. You have to come to.
All right. device management. So you can see the devices, the local device alarms, measurements, and also in the same way in the cloud as well. You should be able to see the device as myown.iot.com. Yeah, this is the device that Edge is shown as. Again, there are some metrics like node and CPU memory usage, CPU and memory usage of the worker node, and also the disk usage of database node. And you can fetch the diagnostics. You can request the diagnostics remotely from the cloud. And you can download this jar file or tar file that would have the diagnostic logs. In the same way, via firmware, you can update the Edge remotely or trigger the update of Edge remotely. This is where the demo starts, the demo ends, and I'll move on to the final. So takeaways, Edge on Kubernetes complements Edge appliance, and it's not replacing Edge appliance. They cater for different use cases. So you might have to judiciously choose depending on what are the capabilities that you would need. But as such, Edge itself, whether it is deployed on Kubernetes or appliance, the functionality remains the same. As I said, Cumulocity IoT Edge on Kubernetes represents a cloud-native solution for delivering and managing Edge. If you want to try out, the user guide is available here. I think this slide deck, when it is shared with you, you should be able to get these details. And the repository credentials, I've provided a 1Password link, which is active till December 23rd. But if you need it later, you can always contact Nick. He would be happily providing you the details. That's about it. Thank you all. Any questions I can, or one of us can answer.
I already asked in the chat if there are any questions, but I can open the mics now if you want to ask a question personally. I know we are already over time, but I want to give you the chance to ask any questions. Last chance, any questions? Three, two, one. I don't think so. Okay, then thank you, Bhaskar. Thank you, Nick, for the great session. See you all in one of the next events. Have a great weekend and a great day. See you guys.